Okay, so example 4 and 5 are actually pretty much the same thing as examples 1 through 3 that we did in that nifty activity in class, or if you followed along in example problems 1 through 3. These are the same kinds of problems. We're just going to be using different kinds of factoring techniques. Okay, so with different factoring techniques comes different ways to find zeros. So if you want to try these on your own, go ahead. Again, we are going to be using different factoring techniques than 1 and 3, so maybe you want to follow along, but if you think you got it, go ahead, go for it. Okay, so in example problem 4, okay, we have, what we're going to be doing is we're going to be finding the factored form of the polynomial and then finding our zeros, okay, which typically you see the word zero for these types of problems. Okay, but I wrote all the ways you can say zeros just so you get used to seeing them. So if you see the word zero, x-intercept, or root, or even solution, okay, you are finding the same thing. Okay, you're basically setting y to be 0. Okay, when you find an x-intercept, you make y 0. When you find y-intercepts, you make x 0. So just keep that in mind. Okay, so let's start factoring this thing. So we have two terms and we're subtracting. So let's look at our nifty chart. Okay, I'm going to look at the two term side since we're dealing with two terms. So two terms and subtracting. So we're looking for a difference, and we're either going to do a difference of squares or a difference of cubes. Okay, so if we have two perfect squares, which means we can square root each of those, then we have a difference of squares. If we have two terms that we can take the cube root of each, then we have a difference of cubes. Okay, so let's see what we have. Can I square root x to the third and 8? No, I cannot. You guys are totally right. Okay, there are not two of the same number that multiplies to be x to the third, and there are not two of the same number that multiplies to be 8. Okay, now don't get confused. I'm not saying 2 times something equals 8. I'm saying the same number multiplied to itself. 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16. Okay, so 8 is not a perfect square, but x to the third and 8 are perfect cubes, which means I can cube root each of these. So the factoring technique we're going to use is a difference of cubes. So this is what we're going to use, a difference, that should be a C, sorry guys, difference of cubes. Okay, which a difference of cubes states if you have two perfect cubes that are subtracting, after you cube root them and get your a and your c, you subtract the a and the c, and then you do a squared plus ac plus c squared. Okay, so let's see what wonderful things happen when we cube root each of these. Okay, so I'm going to take the cube root, my a is going to be the cube root of my x to the third, or my first term, and my c is the cube root of my second term without the subtraction sign. So I'm going to be cube rooting the 8. Okay, so let's see what happens. The cube root of x to the third, well, I divide my exponent by my root. So 3 divided by 3 is 1. So this is x to the first, which is the same thing as x. And the cube root of 8. So I want to know what times what gives me 8. Okay, so 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. So yay, I found my a and my c. So now I'm just going to put it in this formula. So I'm going to do my a minus my c, or my x minus my 2. And then I'm going to square the a term, so x squared is x squared. I'm going to subtract the a times this, or I'm sorry, I'm going to add, silly Miss Long, I'm going to add the a times the c. So x times 2 gives me 2x. Alright, and then I'm going to square my last term. So 2 squared is 4, so plus 4. Alright, you guys, this is factored form. Holy hot dog, right? Okay, now, I'm going to tell you the reason why I knew this was factored form. Technically, you're supposed to ask yourself, could I keep factoring? Okay, which this one we definitely can't factor, because when something is down to x to the first, you guys, we can't factor it anymore. Now, every time you do a difference or sum of cubes, you cannot factor this. You cannot slide and divide. Okay, there are not two numbers that multiply to be a times c, which is 4, and add to be 2. Okay, if we do slide and divide, we slide the a to the c, so 1 times 4 is 4. And remember, we find two numbers that multiply to be 4 and add to be b, which is 2. So there are not two numbers that multiply to be 4 and add to be 2. 1 times 4 is 4, okay, but 1 and 4 don't add to be 2. And 2 times 2 is 4, but 2 and 2 don't add to be 2. So it fails us. So as any time you do a difference or sum of cubes, you cannot factor anymore. You have to stop. Okay, so we have reached factor form. But now, I want to find the zeros, okay, or the x-intercepts, or the roots, or the solutions. They all mean the same thing. Okay, which remember, we do that by setting each of these equal to 0. Okay, so we're going to set my x minus 2 equal to 0. And we're going to set this thing equal to 0. So x squared minus 2x plus 4 equal to 0. Alright, you guys, let's get going. So, my x minus 2 is pretty straightforward. Okay, all we gotta do is solve for x. So I'm going to bring the negative 2 to the other side, which the way you do that is by adding 2 on both sides. Okay, so negative 2 plus 2 cancels and turns to 0, and 0 plus 2 equals 2. So we get x equals 2. This is one of our zeros. Yay! Alright, now I have 3 terms, which only have 3 terms. If you cannot slide and divide or factor of any sort, you have to use the quadratic formula. So that's what we're going to be doing on this one. Quadratic formula. Okay, yeah, so anytime you do a difference or sum of cubes on the trinomial only, so the trinomial is the one with 3 terms, tri means 3, you have to always use the quadratic formula on it, because factoring will never work. Always. So you kind of have to remember that, or you can go through process of elimination. If you try to slide and divide and it doesn't work, then you have to use the quadratic formula when you have 3 terms. Because, for reference our nifty chart, 3 terms, the only options are sliding and dividing and the quadratic formula. So if this one fails us, we have to use the quadratic formula. Okay. Alright guys, let's start rocking and rolling with this quadratic formula. Okay, so first you guys, let's find our A, B, and our C term. So my A is the number in front of the x squared, which is the 1. My B is the number in front of the x, which is the negative 2. And my C is the 4. Alright, let's use our formula. I'm going to write the formula over here so we can kind of reference it. So we have x equals, I'm actually going to use pink. Okay, x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Which I know some of you guys are just singing along to the awesome sum I taught you. I know you were. But anyway, so let's keep going. So x equals opposite of b. So the opposite of my b is a positive 2 plus or minus the square root of negative 2 squared, my b squared, minus 4 times my a term, which is 1, times my c term, which is 4, and then remember, divide the whole thing by 2 times my a, which is 1. Okay, guys, let's get going. So, I'm going to bring this over here so I kind of have more space to work with. So you have x equals 2 plus or minus the square root of negative 2 squared. So negative 2 times negative 2 is 4. Okay, I'm going to multiply all this together, which remember you guys, the negative is attached to my 4. So it's negative 4 times 1, which is negative 4, and negative 4 times 4 is negative 16. And all over 2 times 1, which is 2. Alright, let's keep going. Let's simplify that square root. So 2 plus or minus the square root of 4 minus 16, which is negative 12, all over 2. Okay, so first of all, you guys, I cannot have a negative under my square root. Not allowed. So remember to make it positive, and I is going to hop out. So I have x equals 2 plus or minus I root 12. So now my negative 12 is turned into positive 12, all over 2. Okay, I'm going to bring this up here because I'm running out of space. Alright guys, so I cannot square root 12. It's not a perfect square, but we can simplify the root by doing our factor tree. So I'm going to do my nifty little factor tree. So 12, 2 things that go into 12 are 3 and 4. Okay, and 2 things that go into 4 are 2 and 2. So remember you guys, for my final answer, I'm going to go ahead and set it up so I'll be ready to go. So I have x equals 2 plus or minus I, or actually, hold on. I'm going to leave some space because typically we write the I second. Okay, so I'm going to make sure I have some space in front of the I. Okay. So I'm going to leave some space. So I root something all over 2. So let's see what happens. So remember, you guys, when we have square roots, we're looking for 2 of a kind. Okay, and if we find a pair, remember we circled the pair and they get to leave the house for their hot math date, or they get to leave the radical. And then any ones that don't have a pair have to stay inside of the radical. So let's see what happens. Okay, I got a pair of 2's right here, so they're going to hop outside the radical. And remember, you guys, for each pair, only 1 will pop out. So I have 1, 2 pop out there. Okay, and my only other number at the end of the branches is my 3. And my lonely single 3 will stay inside the radical. Okay, so this is what it looks like. Okay, these numbers pop out in front of the plus or minus sign. Okay, so if you notice, my I popped out in front of my square root, which is in front of the plus or minus. And also this stuff popped out in front of the plus or minus, or right in front of my square root. Okay, so be careful. They don't like hop over to the first 2. They stay in front of that plus or minus. Alright guys, the last step, guess what? We can simplify. So remember, we can simplify if anything goes into these 3 numbers. So I'm looking at only these numbers. Not under the square root. You can never simplify something that is not in a square root to something that has a square root. So let's think. Does anything go into 2, 2, and 2? Holy hot dog, you guys are so smart. 2 does go into 2, 2, and 2. So my final answer, you guys, 2 divided by 2 is 1. This 2 divided by 2 is 1. And that 2 divided by 2 is 1. So my final answer is x equals 2. I'm sorry. Jeez. It's long. Sorry, guys. Oh, man. Alright, 2 divided by 2 is 1, plus or minus. 2 divided by 2 is 1, so I could write 1i, but 1i is the same as I. So I'm just going to write it as I. I leave the square root alone. Don't touch it or the demon cats are coming for you. And then I could say all over 2 divided by 2 is 1, but remember, you guys, anything over 1 is itself. Just like if I have 4 over 1, 4 over 1 is just 4. So I could write this over 1, okay, but it means the same thing as this. So my 2 zeros are these. I have 1 real 0, and these count as imaginary because I have an I, and there's 2 of them. Okay, I have a positive 1 and a negative 1. Okay, a negative 1, or, sorry, you still can't see it. So, a negative 1. Do you see the negative? There, okay. Alright, so remember, the complex conjugate theorem states that we have 2 of a kind whenever we have imaginary, the positive and the negative. Okay, so for my final answer, these are my zeros. Okay, which, let's see, I don't really have space to write how many zeros and the kind of zeros. Okay, I'm going to squeeze it in over here, you guys, since I'm kind of out of space. I apologize. If you want to, you can just write it underneath your work on your piece of paper, like right here. But I did not plan appropriately, and I ran out of space. So I have 1 real 0. So I have 1 real 0. I have 2 imaginary zeros. Okay, and that gives me a total of 3 zeros, which makes sense because my highest exponent I see is a degree 3. So that makes sense. So yay. I have 1 real, 2 imaginary, and a total of 3 zeros, which that makes sense because I have a degree 3. So yay, it all made sense. So again, you guys, I apologize, I kind of ran out of space, but if you want to slide this like right below your work right here, that would probably make more sense. Okay, so that is all we're going to do for example 4. Okay, which example 5 is pretty much the same thing as what we just did, except we're going to use a different factoring form. So get pumped up for example 5.